Hello and welcome all. So let us look at what we have covered till now. So in the compute section, we did cover autoscaling groups, load balancers, instance types, bastion hosts. In the storage also, during the cloud practitioner, we did cover most of the storage part for the S3 perspective, storage classes, glacier lifecycle policies and stuff. Networking, which will focus today mainly. Should I increase the font of it? I hope now it should be visible. So we did cover a lot of VPC security groups, knuckles. So VPC is one concept that is, I would say, if you start giving the priority, I would give this the priority one for your solution architect associate certification. You should be knowing to create a VPC from scratch on your own across multiple availability zones. Spin up EC2 instances in multiple availability zones in a VPC, attach security groups to it, attach knuckles to it, and such stuff that is really important. VPN and Direct Connect, we did discuss very briefly. So there are two concepts: Site-to-Site VPN, which is more of a software VPN between the customer data center and the AWS region or availability zone. Direct Connect would be actually a physical a layer, like a wire between both customer region and AWS for the transfer of the data. VPC endpoints, we did discuss about them also. Towards the end of the session, I believe I'll explain these concepts in more detail: VPN Direct Connect and VPC endpoints, what exactly they do, and why they are important. And that's pretty much that we'll be needing from the solution architect Azure certification perspective. NAT gateway and NAT instance, we did discuss about them in detail during our cloud practitioner. So please go through the cloud practitioner VPC section video in case if you're not aware of these. And then we have transit gateway and VPC peering. We did discuss about VPC peering, that if there are resources in VPC A and there are resources in VPC B, if they need to talk to among each other, then VPC peering is a concept through which two VPCs can be associated so that the communication can start happening between these two VPCs. VPC peering is not transitive. That means if VPC A is paired with VPC B and VPC B is paired with VPC C, then resources in VPC A will not be able to speak to resources in VPC C unless there is a direct connection between VPC A and VPC C. So there has to be one-to-one connection between every VPC that needs communication among themselves. And this is okay when we have 3 or 4 VPCs that we need to connect. But think about a enterprise organization in which there are hundreds of VPCs. Then having a connection between one-to-one VPC would be many-fold, and it's not sustainable. And that is why transit gateway as a concept comes into picture, in which it is more of a hub and a spoke model, that all the VPCs are connected to a transit gateway, and then transit gateway ensures that the communication happens between all the VPCs which are connected to it. And then we do have concepts like a CloudFront, Route 53, and Global Accelerator. So from the networking perspective, VPCs and Route 53 will be the most important one. On a very high level, CloudFront is, as we have discussed numerous times, it is a content delivery network. So in AWS, as we know that we have regions, then we have availability zones, then we have edge locations. Edge locations is the place where your content is cached, so that when, let's say, there is a website on AWS and I want to access the website, and let's say the website is loading images. Every time, instead of going to the specific server to load the images, those images are cached at the CloudFront edge location, so that when the user is requesting for a specific image or a specific resource, then that is served from the edge location. So the overall user experience is enhanced multifold by using CloudFront, which is a content delivery network. So now let's come to Route 53. We'll try and discuss this in detail as much as possible. So to start that, what I'll do is I'll open Route 53 user guide. So what exactly is Route 53? So Route 53 is your, it does multiple things, it is a domain name system. So it's a highly available and scalable domain name system web service. So it is mainly a DNS server for you. You can use Route 53 to perform three main functions. Register domain names, as you know, traditionally you might be using GoDaddy or something like that. So you can use Amazon Route 53 even to register your domain names. Route internet traffic to resources for your domain. So if there is a request that is coming to you, then DNS is going to resolve that, and it will be able to route the traffic that is coming to the specific domain. And we can also check the health of the resources. So we'll go into each of these in detail, but we'll focus majorly on the two, which is the routing policies. That will be the major point in your exam. So for registering domain names, it's pretty straightforward. You need to think of a domain name which is unique enough, which is not already registered, and you will be able to register it directly from the AWS console itself. Now let me see if I should be able to, give me just 1 second. I'll try and log into AWS console and then bring it up. Okay. So now I'm logged into my AWS console. Let me bring it up. So in the AWS console, if you go to services, then if you scroll down, there would be networking and content delivery. Here, if you see, we have Route 53. So when I click on Route 53, it does take me to the dashboard. So there are multiple things that I can do. One of the things that I can do is the domains, registered domains and pending requests. So I can go to the registered domains. I would not be having any registered domain. I can always register a domain or transfer a domain. So in case if I have a domain which I've registered from some other registrar, I will be able to transfer that domain to here, or I can register a new domain. So to click on new domain, I should be able to give it a name. Let's say random site. I'm not sure if this will be available, but let's see. Yeah, it is available. So if you want to purchase, you can purchase a randomsite.com and you'll be able to see the costs here. So that's as simple as that. For you to register a domain, that's one of the things that Route 53 can do. But as we said, the major focus of us would be here route internet traffic to resources for your domain. For that, we need to understand a few of the concepts. I'm not sure how aware you are about the DNS, but do read about DNS, how the DNS works. On a very high level, a domain name resolution is about resolving a name, let's say, for example, example.com, to a specific IP address where that particular service is running. So let's say on a specific IP address, let's say we take up IPv4, it is running on 10.232.5.6, something like that, a random domain IP address. On that particular IP address, let's say if it is running and we have a domain name example.com, then domain name resolver on a very high level, a very simplified version is that it will be able to resolve when you give them that I'm trying to find this particular example.com, it will be able to route me to that particular IP address and the traffic will be routed there. But it's not as simple as that. There are multiple steps that happens in between. There is a name server, then there is a SOA records. There are multiple steps that happens. So I recommend to read about that so that you understand what exactly DNS is and how it works. But from our perspective, let's see what we will be actually focusing here on. So here in this, it's a very huge user guide. No need to go through the entire thing. Registering your domain is fine. Configuring Route 53 as your DNS service, routing traffic to your resources, working with records. This is what we'll have to focus on mainly, that how are we going to work with the records. So there are multiple record types that we need to understand. So if you see this supported DNS record types, so which are the kind of DNS support record types are supported by Route 53? Are these many type? And it might look confusing at the very start, but there are few things that you need to focus on here in terms of which record types are important, and I'll explain them. Not all of them would be required, but it's good to know almost all of them. But we'll focus on the three record types which are most important, which is a record type, then there is a record type or a 4A's record type, and then C name record type. I'll recommend that you go through the all three, but this session perspective, we'll understand what A, 4A's and C name record type are. So A record type is as simple as what I explained right now, that mapping a domain name, for example, example.com to a IP address. So it'll map it to a IP address. If it is a IPv4 IP address, it will be called as A record, and it will be IPv4 IP address that will map your domain name to there. It's going to route traffic to the specific resource. If it is a IPv6, then it will be AAA. So or 4 is record type. So which is using an IPv6 IP address. So that will be the IP address. That was pretty simple. C name is what we need to understand a bit more, which means that for example, you have a subdomains, example.com or example.net, and you want both of them to resolve to a single IP address. Then what you will do is that you will say that example.net resolves to example.com. So it's like mapping one record to another record. That's what would be CNAME record type it is. So go through that in detail, but it's more like giving another name to a specific name is what will be the C name record type would be. Route 53, on the other hand, supports Alias Records, which is kind of an extension, and we'll talk about this. So even here, if you see choosing between alias and non-alias records, that's what it will be routing you here to, choosing between alias and non-alias records. So Amazon Route 53 alias records provide a Route 53 specific extension to DNS functionality. So you have DNS functionality in which we have A records, C name records, but from a Route 53 extension perspective, we have something called alias records. So it is similar to a C name. It also does, kind of giving another name to the actual domain, but there are subtle differences between here, and we need to understand the differences between a C name and alias when we should be using what. Okay, so for that, alias records lets you route traffic to selected AWS resources. So to give an example, we have elastic load balancer. So we did do this in our labs, that we created auto scaling groups in which there'll be multiple EC2 instances, and all those instances will be behind a elastic load balancer. So any traffic that comes to the elastic load balancer will be forwarding it to one of the EC2 instance to serve the request. Now, elastic load balancer itself needs to get the traffic. And how will it be able to get the traffic? So elastic load balancer does not have an IP address of its own. Elastic load balancer only has a domain name. And that domain name is kind of registered with your as a hosted zone in your Route 53. So when a request comes to route 53, route 53 forwards that request to your elastic load balancer. And here, if you see, there is no IP address. So uh, each of your individual EC2 instances might be having IP address, but because they are behind a load balancer, those IP addresses will not be accessible directly to the route 53. Route 53 will have to send the request to the EC2 instance or the specific web server via load balancer, and load balancer has only a domain name. So for that, we do create aliases. So for route 53 to serve DNS query for an alias record, so it responds with one of these. So either I gave an example of elastic load balancer because this is what we have actually done in the lab, but it can be like a Amazon API gateway which serves a request, or the VPC interface endpoints. We'll discuss about this today briefly. Or it can be a CloudFront distribution. So there are multiple like AWS services to which Alias Records fits into. So that ties back to the sentence. Alias Records let you route traffic to selected AWS resources, such as CloudFront distribution or Amazon S3 buckets. So as we know, we can host a static website on Amazon S3 bucket without any compute server or EC2 at all. We can have the static resources on a S3 bucket, and we can host them as a website. Now, how the traffic would be coming to that website? We can have a route 53. We can when we create S3 bucket, S3 bucket has its own name, but you would not be using that name as your website because that will not be very reader friendly. So you will register a domain like a my hosted website or whatever, and you'll be having myhostedwebsite.com. You register this domain via route 53. Now you want to route all the traffic that is coming to this domain to your S3 bucket, and that will be done via route 53, and you'll have to set an alias there. I hope it is making sense. So that's what alias is. For the differences between a CNAME and an alias, please go through this. It does tells the difference, but in a nutshell, if you want to map one domain name to other domain name, it is CNAME. And but if the other domain name is of like a S3 bucket or a CloudFront distribution or something like AWS internal where you want to map it to, it will be a alias records. So there might be questions on which kind of a record type you would be setting, whether it is an alias record or a CNAME or a name. So a name, if it is resolving directly to an IP address, so if it is resolving to directly IP address, it has to be a name, a record. If it is resolving to a domain name, then just see that whether it is S3 bucket or a elastic load balancer, then it will be alias. Otherwise, it will be a CNAME. So go through these differences in detail. Now let's go to the routing policies. So now let's say you have a global website, for example, Netflix. There is a request coming to the Netflix to watch a specific movie, and that request might be coming from any region, like a person sitting in Sydney, or a person sitting in India, or a person sitting in UK, or a person sitting in North America. So there are totally 4 different geographic regions. Uh, it's coming to, right? And the overall URL would be the similar to which we would be requesting. Uh, but the content, first it will be, if it is cached at the content delivery network, it will be served from there. But if it is not cached there and we are requesting the domain, so how the overall routing policy of this domain works is what we are going to discuss here. There are multiple routing policies. So when uh, we register kind of multiple origins which will serve the request, uh, your routing policy, your Route 53 will be having multiple record sets, and these record sets needs to be defined with a routing policy, so that when a request comes to Route 53, it will be able to forward it to the specific record set. So these are the 1, 2, 3, 4, 5, 6, 7 different routing policies which it actually, as of now, Route 53 supports. So we'll go through them one by one, and there will be scenario based questions on which routing policy will be used for a specific scenario. The first one is simple routing policy. So in case if we have a multiple record sets, then using a single resource that performs given function of your domain, uh, it's more of a round robin, or like a random picking. If let's say for a specific web server, they're on 3 different IP addresses, it is going to return to you any specific IP addresses. It will not use any specific algorithm for that. Failover routing policy. So let's say I have, you can compare this with the database multi-AZ, which is a failover. If you have, let's say, 2 IP addresses, the first is primary and the second is a standby or a failover, then all the requests that are coming to route 53 will be routed to the primary, which is your primary instance from where the traffic would be served. In case the primary is unavailable, that's when it will be routing it to the second or the standby IP address. So that's how you can define a failover routing policy. And here, what will be important is setting up the health checks. So as I said, there was initially, there were 3 things that was able to do, right? The first is registering a domain name, second is routing the internet traffic, and third is the health check. So setting up a health check will be really important for failover routing policy. Then the third is geolocation, and this is pretty straightforward in a terms that when you want to route traffic based on the location of your users. So let's say I have a website which is uses internalization, which means that each website is in its own specific language. So anyone who is accessing a website in, let's say, from India region, the website is in Hindi. If anyone is using the website, let's say in UK region, it is in English, but it is using a pound as a currency variable. And if it is in US, it is using dollar as a currency variable. So you will be having these customizations. So you would want that the user, based on his location, that particular website should be loaded. So this is where you can define that based on where the traffic is coming from, which location the user is requesting, uh, that particular IP address, the traffic should be routed to. Geoproximity. This is a bit different from geolocation. Geoproximity defines 2 things. First, it's based on the location from where the traffic is coming, and also based on where your resources are. So, for example, I have my application running in 2 locations. One of the location is, let's say, is my London region. The other location is, let's say, North America, Ohio region. For some reasons, I have more powerful servers on Ohio region and less powerful servers on London region. Then I would want that the requests that are, generated, uh, depending upon what radius I set, that the radius of the Ohio region should be more than the radius of my London region. I'll be able to set a bias parameter, giving more bias to the Ohio region and less bias to the London region. So it is kind of taking the geolocation to the next level. It also keeps the account of where exactly your own resources are being placed and from where the traffic is being generated. Then coming to latency routing policy. This is interesting in terms of irrespective of from where the request is coming, your Route 53 is going to check which region is responding the fastest, and it is going to route your request to that region. So it's all based on the latency. There might be a possibility that whether you are in London region or anywhere, but if the Ohio region is responding faster, your request will be routed to Ohio region. But if there is a scenario based question that you want to load a region specific website using a region specific values, then you need to go to geolocation, and not even geo proximity, it has to be geolocation. Then we have multi-value answer routing policy. In multi-value answer routing policy, it is similar to the simple routing policy. It's just that we will add the health records here. So if you're able to add the health of the records, then it becomes a multi-value answer. Why it is so? It is so because let's say I have a 10 record sets. In case of simple routing policy, I will be given any one of the 10 record set to serve the request. But in case of multi-value, it will not return the ones which are not healthy. So it will only be returning the ones which are healthy, up to 8 healthy records. So yeah, up to 8 healthy records, and from that your request will be served. And then lastly, we have weighted routing policy. uh, it comes to weighted policy, it is more like, let's say I have two regions again, London and Ohio. I'll be able to set the weight. Let's say that 20% of the request should be going to London region and 80% of the request should be going to Ohio region. So based on that, we will be able to route the traffic. I hope all that makes sense. If you have any questions, let me know.
Yeah, Prasad, what is the difference between proximity routing policy, geoproximity routing policy, and weighted routing policy? Difference between these two?
Geoproximity and weighted routing. Good enough. So we will let's dive deep now. Okay. For the weighted routing policy, as I said, okay, probably that was a wrong example for London and Ohio. We have two regions. Our old customer base is in Europe, and we have two regions in Europe, in UK, which is London and Ireland. We want that 80%, or we can define it specifically. We can define it that 80% of the users should be going to weighted and to London, and 20% should be going to Ireland. So if I go down, so here I'll be able to specifically specify that I have these three IP addresses. Each IP address should be having this much weightage, and based on the weight, it will be forwarding the requests. But when it comes to geo-proximity, it is not based on the weight. It is based on the resources and the bias number. So when you'll go through this document, it will be hopefully much more clear. So in the geo-proximity routing, there are two things: AWS resources and where the traffic is being generated. So as you see, there is a bias number that we can provide to them, and based on the bias, your region would be expanding or getting short. So if you see here, region 1, if we are going to change the bias here of the region 1, or for example, if you see region 1 and region 2, so here they added the bias plus 25 on the number 2. So if you see the overall, the scope of 1 got decreased and the scope of 2 got increased. And this is not based on the exact number of requests that it will be routing to, but it will be based on here, let's say there was a user here. With this setting, this particular user will be routed to this particular region. But if you change the bias number, then the user who is coming from this region will be going to the 2. So you're defining the regions based on the bias. Does that help?
If I am understood correctly, let me rephrase it. Like geo proximity is something like based on location. From location, it will be checking the nearest region, right? And weighted is something that we need to configure, right? 80% to some other region and 22.
Yes.
Is that correct? Or?
Yes. Weighted is something that you need to configure. It does not based on
configure.
Yeah, and it's not based on the location of the user at all. Here, okay, it is based on. Sorry.
We need to configure according to how the traffic should drive, right? In weighted.
Yes.
Geo proximity is something like based on location, and based on the nearby location, it will serve. Right?
Yes. Let me explain it a bit more. Weighted, you're absolutely correct. There is no concept of where the traffic is arising from or which region. It is all based on a static configuration that you have done, that how much percentage of request it is being, like it has to be served. The confusion is generally more between geoproximity and geolocation. Your geolocation is, sorry, it is a echo coming. Give me one moment. Geolocation is mainly depends upon the region, that which region the traffic is coming from and where it should be redirected to. Geoproximity takes it to the one level ahead, that which region it is being originated, the traffic is being originated, or which area the traffic is being originated, and based on the bias, it tells the area each of your end server that is serving the request is going to cover. So it depends upon the both your resources that are deployed, that how much area that they will be able to cover, and the request from where it is being originated. And it is based only on the traffic flow. So there is a concept called traffic flow, for which you need not dwell into much, but there's a concept of traffic flow through which you will be able to configure exactly how the data should be routed. And for configuring geoproximity, we need to configure it via traffic flow only. For others, you can configure directly. So there's a difference between geolocation and geoproximity, and understanding that would be important.
Yeah, I'm clear here. Yeah,
Great.
thanks.
Cool. So go through these in detail. So there will be questions on this. Now there is a question from Shitanshu. I'm still unclear about the multi-value. Does it perform checks of max 8 resources? No, so what it does is, and we can go in detail to understand that, but if let's say I have 20 resources, it is going to give you random 8 healthy resources, out of which you can choose one. Okay. Do we have more questions on this? These are the concepts that will be actually important in understanding. So Route 53, where does the name come from? 53 is a DNS port, and route is mainly because it's mainly used for routing traffic, and that is why the name is Route 53. For what the Route 53 is used for, as we have seen in the introduction, it is mainly for 3 purposes: register domain names, route internet traffic to the resources of your domain, and check the health of your resources. Other things that we need to be understanding here is like the whole DNS, how it works, then the different record types, A type, CNAME type, 4A type, 4A types, and there are other types of records that we need to understand. The difference between an alias and a CNAME, that would be really important to understand. And then all the routing policies. If you understand these things, then you are covered totally from the Route 53 perspective. Okay, if there are no more questions, then let's move back to Excel and see what else we should be covering. Okay, let's start from the beginning. VPCs. Security group and ACLs, I believe we have already discussed a lot, so we'll not spend more time there, but we'll definitely spend some time on VPN and Direct Connect. So as I said, there are 2 ways to connect your on-premise data center to AWS. So there are a lot of scenarios in which you would need a hybrid solution when working with cloud. And when I say hybrid, it means that your applications are spread across your current data center and AWS. So in that case, in a lot of scenarios, there will be a requirement that the applications needs to have, these applications which are deployed, in in a different location in your data center and in your AWS accounts, they need to communicate among each other. And to communicate among each other, obviously we can communicate over internet, but that will not be the ideal way to do that. It will not be secure. We need, there has to be multiple considerations in doing that. So depending upon how large the enterprise is, they may opt for a software VPN or more of a direct connect. So we'll look into both of them. So let's start with site-to-site VPN. Okay, we do have here. So we'll start with here site-to-site. So by default, instances you launch in Amazon VPC can't communicate with your own remote network. When you say own remote network, that means that your own data center. You can enable access to your remote network from the VPC by creating a AWS site-to-site VPN connection and configuring route. Obviously, we'll have to have even one resources in one VPC to other VPC. We need to create some routing between them, whether it is in form of peering or some other form. So that the resources will communicate. So we'll need to have some routing configurations so that the traffic is passed from one location to other location. So here, if you see, what we need to understand here is where exactly which scenario it will be used, and what are the major concepts. So for the major concepts, it's like we have a VPN connection, then we have a VPN tunnel. And important point to note here is the VPN tunnel is a kind of an encrypted tunnel where the data can pass from one customer network to other. And then each VPN connection includes two VPN tunnels, which you can simultaneously use for high availability. This is important. So any site-to-site VPN that you create between a customer data center to AWS, then the tunnel that will be there would be in itself redundant in terms that it has two VPN tunnels. Then we do have a customer gateway and a customer gateway device. I believe there would be a diagram. Let me find that out. Yep. So here on a very high level, this is how it looks like. That we do have a AWS network, we do have a on-premise network. There's a customer gateway on the customer side, and there's a virtual private gateway on the AWS side, and there is a VPN connection, which would be a secured channel in which the data would be flowing. And as I said, this would be more of a software VPN. It is not a hardware VPN. Then there's as I said, there's a concept of transit gateway. If the resources in the on-prem needs to talk to multiple VPCs here in AWS network, then it's better to use a transit gateway. And the VPCs which needs to discuss with the on-prem, which needs to communicate with the on-prem, and the on-prem all are hooked into transit gateway, and transit gateway will be able to route the traffic between these networks. So through transit gateway, this VPC will be able to talk to this VPC and vice versa, and this VPC will be able to talk to the on-prem network, and the on-prem network will be able to talk to these VPCs. Yes, feel free to read more about the customer gateway device, though a lot of depth of these will not be required in Solution Architect Associate. They'll be required in networking specialty exam. Okay, VPN categories. There are multiple VPN categories, which is fine. Tunnel options. So here, if you see in this particular diagram, it expands that tunnel here. So it shows that you have a customer gateway, which is in the customer network. We do have a AWS network, and we have a VPC. We have a virtual private gateway for that. But then we do have two tunnels here, which is for redundancy. Each of the tunnel will be having its own kind of a IP. So in case if there is an issue with one tunnel, it will fall back to the other tunnel. So by default, it is inherently redundant. tunnel authentication option is not required. This will be like going into too much details, which will be required for network speciality. I don't think I have seen questions on this even in professional exam. One thing that you would like to understand, which we did discuss about these during our cloud practitioner exam, is defining these route tables. That how these route tables are defined, how if a VPC needs to talk to the internet gateway, we always use IGW. All right. So in case if a VPC wants to talk to a on-prem network, then we do configure the virtual private gateway. We have the site-to-site VPN tunnel. But for the routing configuration, this is how the routing configuration will look like. That any traffic that is being originated from here, this will be the destination. So this routing configuration is something that you should be understanding, that how these are being configured. And that's pretty much on a site-to-site VPN, I would say, which will be required for you to understand. Then it comes to the AWS Direct Connect. There might be questions on when you should be using site-to-site VPN versus when should be using Direct Connect. Understand this, that if setting up site-to-site VPN would be like couple of hours or maximum couple of days. So if a customer needs to start something very quickly at a low cost, it will be site-to-site VPN. Setting up Direct Connect is much more complex. It actually requires laying down a physical connection between the two. So it does take a lot more time and it is a lot more expensive. So this Direct Connect is used by large enterprises who really want a very secure connection between their own data centers and AWS. So what's a Direct Connect? It links your internal network to a AWS Direct Connect location over a standard Ethernet fiber optic cable. So it actually involves laying down this fiber optic cable. One end of the cable is connected to your router and the other end is to Direct Connect router. With this connection, you can create a virtual interface and then you'll be able to communicate between the two. So from the diagram perspective, as it shows here, we do have a customer data center with a customer network with a customer router. We do have AWS with a VPC with a virtual private gateway, or the AWS services like Amazon S3, Amazon Glacier, which do not sit in any specific VPC. And then we'll be having a AWS Direct Connect location. So you will need to have a more of a connection between a customer and the AWS Direct Connect location. This is where your physical optic fiber cable would be required. And once that is done, we do have direct connection endpoint. We have a customer or router endpoint, and then they will be connected among each other. Here also we have multiple LANs for redundancy, and then they are connected here. So if you're interested, dive deep as much as possible. This is a very interesting topic for the networking folks. From the exam perspective, you should be understanding the use cases that where exactly the direct connect is used. And as you can see, through the direct connect endpoint, you can either connect to a virtual private gateway to talk to the resources, or you can talk to the AWS services directly through the direct connect gateway. That means that now even through the customers will be able to talk to the AWS services without even going onto internet. That means via the connect location, they'll be able to speak to the AWS services directly. And this is where there's a concept called VPC endpoints comes into picture, which we'll dive deep in a moment. The concept of VPC endpoints and the private link. So we will talk about those. And very frankly, this is the pretty much on the direct connect that would be required at a very high level. So if we go back to our Excel, let's see. Okay, the next part is VPC endpoints, and I'll also write VPC endpoint and private link. So let's go to the VPC endpoint now. VPC endpoints are of two types: interface endpoint and gateway endpoints. But we'll talk about that like one by one. So VPC endpoint enables you to privately connect your VPC to separate AWS services. What does that mean? So let's say I have a, a service running in a VPC, and that service needs to talk to my storage service, which is S3. And we know that S3 can be accessed publicly via a URL. It's all API based. So for my application, which is running on a EC2, if it wants to connect to my S3 and let's say download an object, that my application, let's say it's a .NET application, it will be using the API to do the same. So it will be, let's say, calling API to download an object. And this API would be actually traversing over the internet. But we do not want that. We want everything to be staying within the AWS network itself. We should be having a private connection between the resources in your VPC and the AWS services like S3. And that is where VPC endpoint comes into picture. So VPC endpoints enables you to privately connect your VPC to the supported AWS services. And VPC endpoint services powered by AWS Private Link without requiring an internet gateway or a NAT device or a VPN connection or direct connection. So this is important. So if you see, without even requiring an internet gateway or a NAT device, we will be able to connect to S3. And for that, there should be some connection between your VPC and Amazon S3 and other services, other AWS services. And that missing link is what VPC endpoint provides. And this is VPC endpoints is based on an underlying technology called Private Link, which we will discuss in a moment. But let's think about VPC endpoint as a black box, what it does and how it does. So there are two types of VPC endpoints. One is interface endpoints, and the other is gateway endpoints. So interface endpoints is an elastic network interface. It's more of it gives you a ENI with a private IP address. And when it gets a ENI, then it's more like then there are two networks which need to talk to each other. So you can always set up a root configuration in your root tables so that you will be able to connect to that service. Then there is another called gateway endpoint, through which you can specify the target exactly. So interface endpoint is more of whichever service you want to access, you need to create a endpoint for VPC endpoint for that. So it's more like attaching a ENI to that particular service and then creating a VPC endpoint. But from gateway endpoint perspective, there is a configuration through which you can directly specify the target, that where exactly it needs to be targeted, and the route table entry would be made for you itself. So this is how initially it started, and it is supported only for two services, Amazon S3 and DynamoDB. For all other services, it is interface endpoints. Which all services is supported is provided here in the link, that is supported via interface through the private link. It's a long list, and you will be able to see, but most of the services that you will be using on day in on day out basis, you will be able to access it, like Athena, Aurora, Autoscaling, ACM, totally it will be there. Obviously CloudFormation is something only to bring the resources up. CloudTrail is mainly for logging. It's not for any specific service that we do. So it depends upon service type of service that you'll be able to see the list of here. No need to remember this list. You'll not be tested on this that specific. What you need to be remembering is that if it is S3 or a DynamoDB, then a gateway endpoint is used. If it is any other kind, then it will be an interface endpoint that is used. For gateway endpoint, you specify the target. For interface endpoint, you need to specify it's more of a ENI that is there, which is used for creating the interface endpoint. A private IP address is assigned to that particular service. So that's the major difference between interface endpoints and the gateway endpoints. Now let's talk about the private link. Okay, AWS private link. I think I should have gone to the user guide instead of a home page. But yeah, let's look what exactly it does. Or no, I think I should be going to the user guide. That gives a much better. It has taken me to the VPC endpoint itself. But okay, so private link is a concept or a technology through which you will be able to uh, create endpoint of any services, whether it is a AWS service or it's your own service. So let's say you have created your own service which you have hosted on AWS, or let's say on your on-premise, and you want to have a private connection to that service. You will be able to use private link, and there are series of steps which you do not need to know for certification associate exam, through which you will be able to create private link. If your service is hosted on-prem and you do not want your connection to leave the AWS network, then obviously you will have to have AWS Direct Connect between your on-prem and AWS, and then you'll be able to set up a private link which will allow resources in a specific VPC to have a private connection with the service that you have created. And that's what exactly is a private link. And because that's underlying technology, you can use that to create VPC endpoints for any AWS services that we were discussing in the previous link. How to do it? So this is the following general steps to create an endpoint service. There are multiple steps through which you will be able to do it. If you can do it for a hands-on labs, it's nothing better than that. You will be understanding these concepts inside out. But this is something that is not mandatory, I would say. There are other important things that based on your time, you should be focusing on. But if you have time and if you have the curiosity, please go ahead and do this, and you'll be able to set up that. On a very high level, see, this is the service that you are creating, let's say, and for that service you will need to have a network load balancer in front of that service, and then you'll be able to create this private link between the actual AWS service and that. So that's pretty much that I had to cover on the private link VPC endpoint. Tips for the exam would be that there are two types of VPC endpoints: interface and gateway. Gateway is mainly for S3 and DynamoDB, and you can be able to provide the target on its own. Interface is for almost all the services which are for which it is provided, and it requires a ENI with the private IP addresses. You can create your own VPC endpoints using the private link. And in case if your service is hosted on-prem, you would be needing a direct connect between your on-prem and AWS. Okay, so let's move on to our Excel and see what's remaining. I think we have covered enough of transit gateway, enough of VPC endpoints, NAT gateway and instances that you understand. Transit gateway and VPC peering, we did discuss that. CloudFront, we have discussed it a number of times, but let's see if we can find more information on CloudFront. So CloudFront is a web service that speeds up distribution of your static and dynamic web content. So this is also important. CloudFront is not only for static, it can be used even for dynamic web content. It delivers content through a worldwide network of data centers called edge locations. As we discussed, we have regions, we have availability zones, then we have something called edge locations. Edge locations is what forms a part of content delivery network, which is of the Amazon CloudFront. When a user requests that serving through a CloudFront, the user is routed to the edge location first, and if the data is there, it will be able to provide the data to the user in a very low latency manner. And if the content is not available at the edge location, it retrieves it from the origin. So origin is, in case it's a static website, it might be your S3 bucket. In case if it is a dynamic website, then the origin might be, let's say, API gateway or EC2 instance. It depends upon what your origin can be. And you would be, it will retrieve the data from the origin where the actual service is hosted, and it will be caching it, and then it will be serving it. Now there will be a concept of TTL. TTL is time to live. So your CloudFront will be caching the data till the TTL, and when the TTL expires, it expires. So even if you, let's say, change something behind the scenes, users will not be able to kind of see the changes, and the reason of that is TTL, because the edge locations have cached the data, and the data is being served from the edge locations, and the TTL is not expired, so data is not getting refreshed at the edge location. And if it is not refreshed at the edge location, then users will be seeing the old data itself. So to overcome that, there is a option to invalidate the data. So through the API or through the management console, you can always invalidate the cache. There are multiple options. You can always reduce the TTL, so that the time to live parameter is reduced, so that the caches are going to expire the data after that time, and they'll be pulling the data, retrieving the data again from the origin. Or in one go, you can invalidate the data, and when you click on invalidate the data, it will be invalidating or removing the data from all the edge locations. It does come with an extra cost, but that is something that you'll have to do in case if you have changed something in your static website and you want all the users to immediately reflect the changes. Okay. One hands-on lab that you should be doing on your own, and it is part of the initial quick labs that I presented, which is create a S3 static website, host it on S3, create a cloud distribution of that website, so that the website is accessible via the cloud distribution link, not via the S3 link. And why that is important here, let's say I have created a S3 bucket in my region. So S3 buckets are regional, right? So you create a S3 bucket in a specific region. So if I create a S3 bucket in a London region, then anyone, and if I do not create a CloudFront distribution for the same, then all the users who will be accessing my website from across the world, every time they will be accessing my S3 bucket to download the data, irrespective of whether traffic is coming from North America or coming from Sydney region. So the overall response time of the website for the users would be very high. So the user experience will not be good. So in case if you set up a CloudFront distribution for the same, and disable, like it's more like S3 bucket is accessible directly from the CloudFront distribution only, then uh, when your users will be accessing data from anywhere in the world, the first it will be going to the edge location, and the data will be served to them at a much faster rate. It's a very simple hands-on exercise, which you should be doing it on your own. To understand that concept, then you'll be able to understand the concept of origin, the concept of edge locations, the time to live. You'll be seeing the option how to you can configure the parameter time to live, and how you can invalidate the cache. uh, that will be pretty much for. So let's see how what the specific. Yeah, this is what exactly I was explaining. If a developer is actually you're having S3 bucket or HTTP server as your origin, or your objects are here, but when the user are accessing them, they're accessing them via the CloudFront web distribution. And your web distribution, while defining your distribution, you do define that which all edge locations you want it to be cached. So it's more like, where your users are, and you can set up your edge locations accordingly. So here is a step by step that how you would be able to configure your CloudFront deliver content. Do follow these to do a hands-on lab. Okay, that's pretty much. There's one customization, which is this customizing using Lambda at the rate edge. I'm not sure if this will be a part of your solution architecture, but it's a very cool concept to understand. So let's say if you want to do some customization uh, before delivering the content, and doing that customization always at the origin would might prove very costly, and it might be a very kind of a high response time for the user. So there's a concept of Lambda at the edge. Lambda, as you know, is a serverless offering where you will be able to do the processing. It's more of a compute resources in a serverless fashion, and there is a possibility that you can execute these lambdas at the edge locations. So this is a small transformation that you want to do, then you will be able to do at the edge location itself. For example, the numbering system. Few people in the world use a dot as a separator, uh, and at few and dot is used as a decimal at some places. Vice versa, comma is used as a separator at some places, and comma is used as a decimal in some places. So representing the data, so the static content remains the same. I want to show the value 22.56, but that point is either a decimal point or a comma or a dot or a comma. That needs to be configured based on the region in which the user is accessing. That people from, like, let's say Denmark generally use a comma instead of a point to define the decimal. That kind of quick processing can be done at the edge location using the lambda to how to represent it uh, at the end. So there are four, places. It's like when a CloudFront receives a request from a viewer, it's a viewer request, and before the CloudFront forwards the request to the origin, it's a origin a request. Similarly, when the response comes, in the response we have origin response and the viewer response, and we will be able to run the lambda at the edge at any of these places based on what exactly do we want to kind of modify. If you want to modify the request, it will be either the viewer request or the origin request. If you want to modify the response, it will be the origin response or the viewer response. So do have a read at this. It's a good concept to understand. Okay, let's go back to our Excel and see what else is remaining in the networking portion. Global Accelerator. Okay, I think we can cover this very quickly. It's not a like a big concept to understand from the perspective of what is required in solution architect associate. So again, a global accelerator is a concept through which you would be overall. It's mainly to improve the performance of your application. As you can understand from the word itself, accelerator is mainly improving the performance of application for your local and global users. It directs the traffic to the optimal endpoints over the AWS global network. So it's more like, and this is different from CloudFront. When you enable or you configure the AWS global network accelerator, then irrespective of where your application is hosted, your request would be first coming to the nearest location where it will be able to find the AWS network, and rest of the traffic flow would be within the AWS network. That's what the AWS Global Accelerator is. So just understand from the concept perspective that why it is used. It is used to improve the availability and performance of the applications. It is again it's for the global audience, for which all regions it is there in the table at which all regions it can be enabled for. Let me look if there is a cool diagram, which I'm not sure if there will be. No need to go into deep detail that how it works or what component it requires. just understand it from the use cases perspective, that in which of the use cases you would be needing them. Scale for the increased application utilization, acceleration for latency sensitive applications where you will need, let's say, millisecond latency. That's where you should be able to enable them. Disaster recovery and multi-region resiliency and protect your application. So understand the use cases, and that should be good enough for AWS Global Accelerator concepts point of view. And I believe that is pretty much that I had to cover from the networking perspective. So from the overall course completion perspective, from the AWS Solution Architect, we have covered databases in quite a depth. Do go through the Redshift. I don't think I covered the Redshift. We have covered networking. We have covered compute. We'll cover a bit of serverless Lambda and API gateway in one of the sessions. Storage, we have covered quite a lot. And then we have other services that we need to cover. So probably a couple of more sessions, and we will be able to go through all the concepts at a high level, but nowhere it is comprehensive. You will have to do your hard work. It will not be like Cloud Practitioner. Cloud Practitioner is pretty simple. For those of you who haven't given Cloud Practitioner yet, feel free to go ahead and give it. It's quite simple. It's not complicated at all. Just give few practice tests, either Labs or any other practice tests of your preference. Conceptual wise, you should be knowing things by now, and it would be pretty easy for you to go through, get through the Cloud Practitioner certification. But on the other hand, Solution Architect Associate would require you guys to study a lot more. If you are using some course like Stephen Marwick or a Cloud Guru, that I see there was a chat going on in our group, which is great. I myself have used these courses to get through these certifications, so that will always be helpful. If not, go through the FAQs, go through the user guides that I am showing you. You'll have to have much more hands-on and much more depth for all these concepts. I hope the session was useful. With that, I'll open the floor for any questions that you guys might be having. No questions? In that case, thank you everyone for joining today's session. I hope it was useful, and I'll see you next week.